This is Dr. S. Mohan Lakshmi, Professor and Head, Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology, Kanyakumari District. So, in this lecture, we are going to see what are the challenges introduced by 5G in IoT middleware. So, in this aspect, we will see two things. The first thing is technological requirements for 5G systems and usage of a particular middleware which is called as a compass. So, on completion, the students will be able to list what are the requirements, preferably a technical aspect for 5G systems, and they will be able to examine detail all the technological requirement needed for the 5G system, and they will be also able to explain what is compass middleware. So, technology requirements of 5G systems. Of course, we know we are proceeding towards the 6G. So, 5G is a promising technology that has been considered the next step for a long-term worldwide evolution of mobile communication. 5G is intended to be the major component of the network or IoT mission to mission oriented society. It helps to realize the IoT vision toward unlimited access to information and sharing of pervasive data, that is, anywhere, anytime, for anyone, that is, human centric approach and any device, things oriented approach. So, what are the technological requirements of 5G systems? So, I have listed a certain thing which is massive system capacity, higher ubiquitous data rates for real life condition situations, very low latency for next generation networks, ultra high reliability and availability for mobile connectivity, very low cost and energy consumption for mobile devices, virtualized network technology support. So, these are the requirements which is essential for the 5G systems. So, coming to the first one, which is a massive system capacity. So, massive in the sense it is a very high. So, this refers to our data traffic demands, higher data traffic demands, and higher number of IoT devices and applications that could be connected to the internet in the 5G era. So, another aspect of this capacity is that capability to support a much larger number of IoT devices and applications compared with today's requirement. So, the 5G based IoT applications include, for example, the deployment of billions of wirelessly connected sensors, actuators, other mobile devices, but allowing that each device will be associated with very little traffic, implying that even jointly they will have a limited impact on the overall traffic volume of the network. So, here we need a more number of devices to be connected, either mobile or sensors, actuators, whatever device, whatever you think, whatever objects you think that need to be connected in large number, but still this to be connected with a very little traffic. Second factor is higher ubiquitous data rates for real life conditions situations. So, higher data rates, which means that the data rate that can be actually provided under real life conditions in different IoT scenarios. So, the data rate requirement for 5G, at least it should be 10 Gbps in specific scenarios such as indoor and dense outdoor environments. 100 Mbps it should be achievable in urban and suburban environments. At least 10 Mbps should be achievable essentially everywhere, including sparsely populated rural areas in both developed and developing countries. So, here we have mentioned three different data rates: 10 Gbps, 100 Mbps, at least 10 Mbps. Depending upon the environment, so whether it's a urban or suburban or rural area, or it is a dense populated or indoor, so it depends upon the environment. And the next one is very low latency. Latency is the delay, it relates to the delay for next generation networks. So obviously the target or the key target is lower latency network. So the 5G research community is targeting higher data rates, which itself will drive a need for very lower latency. So for example, if I'm having a very higher data rate, obviously my delay will be less. So to support such latency critical applications, 5G should allow an end-to-end application a latency of 1 millisecond or less. The next factor is ultra high reliability and availability of mobile connectivity. So 5G should enable mobile connectivity with ultra high reliability and availability. So which means that it should be highly reliable and it should be always available. For critical services such as healthcare monitoring systems and traffic safety, connectivity with certain guarantees such as specific maximum latency should not only be typically available. So, which should be like every time it should be available, or there should be some guarantee that there will be a connectivity with maximum or a specific latency. Rather, ensuring connectivity with the specific requirements, it should be always available, which means that availability should be always there, and essentially with no deviation, which means that it should have a higher reliability. Then next factor is very low cost and energy consumption for mobile devices. So obviously this will be the key requirement since the early days of mobile communication. That's right from the mobile communication. Once we have started using, we were looking only out for the very low cost and the low energy consumption. Okay. However, in order to enable the vision of billions of wirelessly connected devices, a further step has to be taken in terms of hardware cost and energy consumption. So, it should be possible for such IoT or 5G devices to be available at very low cost with a battery life of several years without recharging. The last one is virtualized network technology support. So, the thing is here, the cost and the deployment flexibility will also be considered as an important factor in 5G network, requiring a shift toward software based implementation and virtualization technologies. So, you need to realize some virtual network. In particular, 5G systems will be able to create multiple virtual core networks tailored to the specialized requirements of particular application. For example, say the system could create a virtual core network to support a machine to machine, a separate virtual core network to support the internet content, or a virtual network to support operator differentiated media services. All of these things should be configured by dynamically utilizing the network resources either from the same network or from the different network. So there should be some visualization of a virtual network which forms the another and the final requirement. And coming to the compass middleware, so this is one of the requirement with the that is the perspective with respect to the 5G. So this is actually the expansion of this one is a cooperative middleware platform as a service, which is an IoT middleware system that has been tailored to support the 5G technology integration. So basically, we have certain goals of the compass. So certain thing like almost 4 goals are there. So one is the abstraction. So abstraction of the integration and interoperation between applications and physical devices through the provision of hierarchical system services according to device profiles. That is, there should be some set of functional characteristics describing each physical device. The next one is abstraction of the collection and the management of data provided by the physical devices through the provision of application level services. The third one is providing high level services to facilitate the development and integration of IoT applications. And even there should be a provision of software architecture based on the IoT or machine to machine. So these are the goals of compass middleware, and you could see in this diagram. So of course the layers will be your physical level, then intermediate, then finally your application level, and here these are the modules of the compass. So where you will have a communication service, and in the second layer you can see a resource manager, resource handler, event handler, and the top layer will be of collection service, operation service, query, administration service. So mostly it is related to the services. So the above figure just now I told you, it presents the organization of the modules of the middleware. So all the services are part of the middleware API available to applications except the communication service, which is used for both application and logical devices. So here the rest of the modules, the resource manager, handler, event handler, allows the integration with the logical device. So here, so these are the possible assessment questions. So what do you mean by the massive system capacity, and what should be the intended data rate requirements for the 5G, and what should be the latency for end-to-end application, and the compass architecture, so that is the compass middleware architecture. So that is the thing. So where it has both the communication module and the service module. Thank you.